Hey everyone, thanks for joining us this evening. My name's Nate Sparks. I'm the chair for the Central Indiana section of the Audio Engineering Society. We have a great webinar lined up for you this evening on the history and development of Shure auto mixing. I'm so excited to see these two presenters tonight and hear what they have to say, hear what they have to share with us on this topic. I know you are too, so we're going to keep this short before I hand it off over to Jay. First, I want to mention to check out the Audio Engineering Society's website, www.aes.org, for all the latest society news, research, benefits, and announcements. That includes events and webinars such as the one you're watching now. If you're not a member already, I highly encourage you to join. We have some amazing benefits to offer for students, faculty, and industry professionals alike. So for a full list of benefits and more info on how to join, you can also check that out over at www.aes.org. Of course, you can also reach out to your local section for more info or help on specific things going on in your region. That also includes questions about membership. We here at the Central Indiana section are also glad to help you in any membership or any questions for that matter relating to Audio Engineering Society. Our website is located at www.centralindianaaes.org, and you can also find us on Facebook by searching for Central Indiana AES. All of that contact information that I just said can also be found below in the info section of this video. Also, if you like what you see tonight, go ahead and hit the thumbs up button, and while you're at it, hit the red subscribe button. You'll get a notification of similar events that we post to our YouTube channel. I'd also like to mention that we plan to fit in some Q&A at the end here, so if you have a question at any time during the presentation, please put it in the chat window and we will pass those along to our presenters, and we will come to that at the end. So anytime, go ahead, put it in the chat window, and we'll pass those along and try to get to as many as possible. Without any further delay, I'm going to pass this over to fellow committee member Jay Dill for introductions.
Hey, thanks, Nick. It's truly my privilege and honor to introduce these two longtime friends for tonight's event. First, Mr. Michael Petterson. Michael is the Director of Corporate History and has been embedded at Shure Incorporated since the Gerald Ford administration. Let that soak in. He's a contributing editor to the massive Handbook for Sound Engineers Missile and a sole author of numerous pro-audio technical papers. In addition to being a published composer of choral arrangements, he is also a co-author of a biography about jazz guitarist Freddie Green. And those of you might remember Freddie Green, 50-year veteran in the Basie Group. And as you can tell from his photo, Michael is a fan of the big body, six-string guitars. Thanks for joining us, Michael. Also on tonight's bill is Mr. Gino Sigismondi. Gino is an Associate Director of Technical Support and Training at Shure, and he credits Sire Petterson with everything he knows. Although it may not be immediately apparent in his young, boyish good looks, Gino is a 25-year veteran in the music and audio industry. From humble beginnings with Shure, he has earned his way to overseeing what is the best technical support staff in the audio industry. And with his abundant spare time, Gino has also been the author of several Shure educational publications, such as Selection and Operation of Personal Monitors, the Audio Systems Guide for Music Educators, and the Selection and Operation of Audio Signal Processors. Quite a lot of accomplishments for the man. And just to set matters straight, Gino is no slouch on a solid body six-string electric. Gentlemen, thank you very much for allocating your valuable time this evening for our AES section. And please know that we all appreciate this very, very much. Michael, Gino, the virtual stage is yours. Thanks, guys.
Thanks, Jay. Gino, get the slide up there, please. We'll start out. Said such nice things about me, Gino. It's so kind of you. So, the evolution of automatic mixing. I laughed with Jay because Jay asked me to do this because I was there at the birth of a lot of these automatic mixers. So we go back that far. But let's take a little review of where they came from and perhaps my learning curve as well. You've already seen Gino and myself there. So the agenda is, why do you need automatic mixing in the first place? Some of the early automatic mixers that are out there. We'll talk about Shure and Telemix. Then we'll turn it over to the digital age, to the younger guy. Automatic mixing goes digital, and then some Q&A at the end of it. Slide, please. So why automatic mixing? Well, basically, you have too many open microphones, you got problems. If you're running it, you're going to get a buildup of background noise and reverberation. Every time you add another microphone, you can just add more noise. If you're running a sound system, a public address system, sound reinforcement system, you're going to get poor gain before feedback. And of course, you're going to get comb filtering. You have one talker being picked up by multiple microphones at different distances away from the talker, you get comb filtering. And that illustration there shows you what comb filtering looks like. Instead of a nice smooth frequency response, you get all these peaks and valleys, which look like a hair comb. As you can tell, I don't need a hair comb, but I do remember them. Next one, please. So how do they address that? Basically what happens is that by keeping the fewest number of microphones on at any time, you reduce the buildup of background noise by attenuating the microphones that are not needed. Think about a city council meeting. You might have 12 microphones in there, one person's talking. Why have 11 other microphones on when you only need one? So that shutting those other ones off, actually just attenuate them. You usually bring them down 15 dB or so. That keeps the background noise low. Poor gain before feedback. Every automatic mixer worth its weight has what's called NOMA, number of open microphones attenuated. And basically what happens is that when the number of open microphones goes from 1 to 2, 2 to 4, 4 to 8, every time it doubles, the output gain is lowered by 3 dB, just like if you had your hand on the master knob and you reduced it by turning the master down, but it does it automatically. So that's called NOMA. And of course, comb filtering, by activating only one microphone per talker, you basically have a better sounding system. Comb filtering is, I'll do my best imitation of comb filtering. It's kind of, when it sounds like this, that kind of nasal sound is what comb filtering is. So there you go. Automatic mixers are made to cure those three things. Slide, please. So some of the design objectives. If you're going to make a decent automatic mixer, what do you design into it? Well, number one, you have to have the automatic mixer keep the sound system gain before the threshold of feedback, and that's what the NOMA circuit does. You really don't want to have an operator or a sound technician sit at the controls. When we talk a little about Dan Dugan later, Dan Dugan, who's the father of automatic mixer and taught me everything I know about automatic mixing, was basically in the early 70s doing theater, and he just got tired of turning microphones up and down and up and down and thought there's got to be a better way to do that. So that's what the idea of the automatic mixer is, to reduce or eliminate. It doesn't eliminate the job of the sound technician. It just gets rid of that really boring thing of turning the gains up and down. Good automatic mixer shouldn't introduce undesirable noise, since they're basically some type of gate or some type of gain control, and you don't want to go in clicks and pops and so forth. They should be installed as easily as a conventional mixer. Early on in the late 70s and the early 80s, when I was a product manager and brought out some of the automatic mixers, our competitors were incredibly complicated. They had probably 5, 6 adjustments on each input, and that was just, for most people, too much to handle. You should have them respond only to speech input signals and be able to tell somehow between the difference between speech and ambient noise, which is not speech, like air conditioning noise or fan noise or something. You have to have the input controls, so the input channels gate fast enough so that there's no audible loss of the speech signal. When someone says the word gate, you don't want it to sound like 8. So that's another thing. So you have to have the channel come up very quickly. You have to allow more than one talker on at a time because there are discussions going on. I remember there was one automatic mixer in the 70s that's what they wanted. Only one microphone at a time. Well, that's okay as long as you only have one talker at a time, but most meetings don't look like that. Some of them also had the ability to compensate for a range of talker input levels, from the very soft talker to the big guy like this. So that's something, not all automatic mixers have that, but that's another thing that can be put in there. And then automatic mixers also usually control some type of peripheral equipment. It could be a camera switching on and off. It could be a tally light letting you know your microphones are on. So these are kind of like the 9 basic objectives of any automatic mixer. Next, please. So some early automatic mixer. Isn't that a great, those of you who know Dan Dugan or don't know Dan Dugan, here he is around 1980. Dan still comes to many, the AES show, you know, when it's not virtual, and he usually has a booth. But this is a guy that basically wrote the first patent, and there's an article he wrote in 1974 laying out the concept of automatic mixing, and it's still valid today. So I found I don't know if Gino knows this, but not too long ago, probably within the last 6 months in the Shure archives, I actually found a letter written on hippy dippy letterhead from Dan Dugan to James Cogan, who was the president of Shure, offering us the automatic mixer first before he went to LTEC. In the mid 70s, we were so caught up with the phonograph cartridge market that we just basically ignored it. And so he went to LTEC, and LTEC brought out the first Dugan automatic mixer. But I love that shot of Dan. He doesn't look much different now, except he's all gray. Next, please.
Michael, that doesn't surprise me at all, given all the things you found in the Shure archive recently.
Yeah, it's never ending. So let's talk about some early automatic mixers. Actually, Shure had something very early on, in the early 1970s, called a voice gate. I wouldn't call this a true automatic mixer, but it was an attempt to have microphones that would gate on or gate off based upon voice activation. So you would have one voice gate per input, and you would adjust the threshold, and it would turn the microphones on and off. There was no NOMA. It did not do any mixing. You actually had to take the outputs of the voice gates and go on to a mixer of some sort. So it's an early noise. It's an early noise gate that was used for microphones. Rowland Borg also had something similar to that. But it was the mid 1970s where Dan came up with the patent, and it was the gain sharing, which is still a lot of people refer to that as the Dugan patent or the Dugan method, and it really worked well, and it still works well. JBL had a system back then, never too popular. It had a lot of adjustments to make. It was basically a sophisticated noise gate with some NOMA and some, what else did it have in it? Yeah, it's NOMA and some attack and release times on it. And also Biamp, Electrosonics, Ivy, TOA. IRP was actually a really big company that made industrial research products. I don't think they're around anymore. They were bought by Knowles, and they actually had some pretty good automatic mixers that worked on a very strange method. Maybe I'll be able to show you that to you later. And then, again, we mentioned gain sharing there, and also, I guess I kind of covered that all in one. So there was a variable threshold and gain sharing, but we'll talk more about it as we get into the different slides. So next one, please. Well, 1981, I had started to work at Shure in 1976. And yes, it was the Jerry Ford administration, Jay, and I really appreciate you telling me that. And one of the first projects I got was, okay, Michael, you have to work on an automatic mixer. I said, yeah, sure, that's okay. I had no idea what an automatic mixer was. I hadn't never even heard of an automatic mixer. And so I get these drawings from our engineering department, and our system just had probably, 10 adjustments for each input. The engineers had just gone crazy. So I figured out I had better find out very quickly what an automatic mixer did. So I went out and started talking to installers who were putting in automatic mixers. And at the time, LTEC was fairly popular, IRP was fairly popular, and some JBLs were popular. The contractors, I understood the concept very quickly, but all the contractors said to me, the problem with them is they take too long to set up. And can you make something, if you make something really, really simple, it'll sell well. Well, we had this concept, being a company that makes microphones and mixers at the time, of making special microphones that worked with a special mixer. And we came up with what was called the automatic microphone system. And what it was is you had microphones which had two elements in it. They were back to back. So you had a cardioid mic that faced forward towards the talker, and a cardioid mic that faced backwards away from the talker. And the front capsule, the talker capsule, went back on pin 2, and the ambient capsule, if you will, went back on pin 3. What the mixer did was it constantly compared the output levels of the front capsule versus the rear capsule. And when the front capsule was 9 dB, louder than the back capsule, the microphone would gate on. Gate on time was about 3 milliseconds, if I remember correctly. Now, what this gave you was a very specific 120-degree gating window. if you turn the microphone to the side and you talk into 90 degrees away from the front, you could not gate the microphone on because you were equally loud in both capsules. You could scream your head off, scream as loud as you want, the microphone wouldn't gate on. Then move it on axis where you're talking in the front of it and barely whisper, and it would come on. When I showed this to some consultants, they thought there was black magic going on. They could not figure out how you could do that because they were all thinking about, this is a noise gate. If so noise gate, you can't do this. But what we actually were doing was a comparative system. These things really worked well, and they were very simple. You can't tell really, maybe you can tell by the photograph. Basically, you had on the input, on the front side, there was an on-off switch and a volume control, and that's all there was. There were some more adjustments on the back, but to make it work, you basically plugged in the microphone, turned on the switch, and away you went. So we had a surface mount microphone you can see there. We had a kind of a probe style microphone like you would hold in your hand. We had the world's largest lavalier. It was about the size of a large Tootsie Roll. And then we actually had a gooseneck as well. But from 1983, when this was introduced to, I think it probably went up to 1995 or 96. If memory serves, there were 300,000, 400,000 channels of this installed around the world. Next, please.
I'll just add that I think that it was actually, I started Shure in 97 and it was still there because that's when we actually updated the look of the mixer. Unfortunately, we never updated the look of the microphones.
Yeah.
So that might be when people wonder why that system doesn't exist anymore because of how well it worked. I think one of the reasons was because you were locked into those microphones. You couldn't use any microphone you want. You had to use the AMS mics. And by about 2000, which was probably about the time it finally went away, the mics still kind of looked like 1980. So.
Yep. And now you see them on eBay, people trying to sell them, and I just think, oh my God, people are going to get these things. They're not going to work because they only work properly. There was a quote unquote phantom power, but it was 7 volts, and it was a current driven system. So, but I got to tell you, it really worked well. And though we never installed many big legislatures, we didn't do the U.S. Congress and so forth. These things were just used everywhere in city councils and PTA meetings and smaller conference rooms. I think the largest system we ever did might have been, I think it was in Europe, and we did 110 channels, something like that. So anyways, so now we get to, there was Shure at the time in the 80s, Shure had a division called a teleconferencing division. And they had introduced a product that had a different type of automatic mixing in it. It did not have the dual element microphone. It was called Type 2 gating. Isn't that an exciting name? Type 2 gating. But it allowed you to use standard microphones. And this was a really clever system designed by a guy named Steve Julstrom. I would say unequivocally, after Dan Dugan, the guy who did the most for automatic mixing around the world is a guy named Steve Julstrom, and Steve worked for Shure at the time. So he came up with a thing where he came up with called noise adaptive threshold gating. So, of course, the AMS was noise adaptive in a way because the rear capsule would look at the noise. But Steve had a way with a very clever analog circuit, remember this is all analog, to basically look at, with a single element microphone, to look at the ambient noise in the room. And Steve's circuit defined ambient as anything that was consistent in amplitude and frequency. So hum of a fan motor, HVAC, things like that. Something that was ticking, tick, 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 that would not be it. But anything that was not speech-like was considered ambient. And whenever that channel had a signal that was speech-like, that was 1 dB above the ambient, it would turn on. So this really worked quite well. There were some other circuits on there as well. I think we're going to talk. I can't remember, Gina. Do we have a little bit more? Don't go to the next slide. But do we have a little bit more about max bus and so forth in the next one?
Oh yeah, that comes up later.
Yeah. Go back. So what we did was the first product. I was a product manager there, and the first product we brought out that was not designed for teleconferencing, but used noise adaptive threshold gating or type 2 gating was the FP410. And we thought we needed a more clever name for that. So actually that type of gating is called IntelliMix. It's actually a term that Shure still uses today. And IntelliMix was 3 circuits operating at the same time. One was the noise adaptive threshold that determined when to turn the microphone on. The second was called max bus. And what max bus did, very simply, was when multiple microphones heard only one talker, the mixer would activate the microphone that heard that talker the loudest. So that basically means one talker wouldn't kick on more than one microphone. And then the third circuit was last mic lock on. And that's a very simple thing that the most recently activated microphone stays on until a new one comes on. And therefore, when you're listening to a broadcast or whatever, the ambient stays the same. So those three things, noise and depth threshold, max bus, last mic lock on, all mixed together was IntelliMix. And so the FP410 shown there on that slide was it. This was battery operated, or AC operated, and we sold these things to broadcasters. Now, broadcasters in 1990, they really didn't know what automatic mixing was. Automatic mixing was still new, and I remember spending a lot of time traveling to ABC, NBC, CBS, Cable News Network, and doing demonstrations of this. You know, we would take 4 microphones, and there was a switch on the front that said manual and automatic. So we had 4 microphones set up. We'd plug a set of headphones in. We'd talk, and then let them listen, and then we'd switch to automatic. And of course, you'd hear the background noise level drop, the comb filtering go away, and their eyes would get real big, and they would buy them. So this is really very successful for it. And this is around 1990. In fact, in 1990, FP410 won the best new audio device at the National Association of Broadcasters show. Slide, please. So I kind of jumped ahead a little bit. IntelliMix automatic mixing, how it works. So you have the gating threshold that's set above the ambient noise level. Again, the ambient noise is something that's constant in frequency and amplitude. And the mic channel activates for speech above that threshold. And the amount is literally only 1 dB above the ambient noise. Next, please. So again, I got a little bit. Oh, off attenuation. Didn't talk about that. Off attenuation is just simply when the microphone is off, how far down does it go? You don't need to make it go down to infinity or minus 60. Actually, with a lot of experimentation, if you just attenuate that microphone 15 dB from when it's on, that's enough to give you all the advantages of automatic mixing. So on most of our mixers, the FP410 had a switch. You could select minus 15 decibels of attenuation, off attenuation, or infinity. Minus 15 worked just fine. So there you go. There's your automatic mixing glossary. That's a nice slide, Gino. Thank you. I appreciate that.
No problem.
Please.
I'm actually going to jump back one because I realized I didn't have another slide for the 810 specifically and how that came about.
So there's the 810. We still make that. That's been in the line since 1995, I think, probably. As a matter of fact, that mixer was designed in one afternoon with myself, Matt Anderson, and John Tatulis, who both worked at Shure at the time. And we came up with the FP410, the SCM810. Those of you in the industry may know John and Matt because John and Matt left Shure in 1997 and formed a little company called Sound Devices. And of course, Sound Devices has become an incredibly successful company. And just a little sidebar, Gino knows the story. I was very honored when the first sound device product that came out was the MP1, named after me. So that was just a really nice thing for those guys to do. But we did that in one afternoon. We just sat down and said, how we could do this? So we brought out that the SCM810. There it is, 8-channel, no battery operation, designed for sound contractors. And this thing is, God knows how many of these things have been installed. But again, they're simple. You'll notice on the front, it's simply a volume control. And that's what we wanted to do. So yeah, it's been a great product.
Mm-hmm. And we actually then came out with a 4-channel version later on, the SCM410.
Oh, I forgot about that. Yeah, the SCM410. Right? Yeah. Didn't do much with that one.
Yeah, I can't remember if we still make that one or not. The FP410 is definitely gone, but the 810 still in the line. So
Yep. Yeah, and of course, as a manufacturer, we're having problems making it now because it's hard to get potentiometers. Nobody wants to make potentiometers anymore, So you got an analog product here, and that's the case. So I had lunch with Steve Jolstrom not too long ago, who I think now probably has like 25 patents to his name. And if any of you are fans of the Big Bang Theory, Steve Jolstrom is Sheldon. This is the audio example of Sheldon. And I remember sitting across for lunch, and I just said, Steve, have you thought much about the IntelliMix and noise adaptive threshold and so forth? And he looks and stares off into space, and you feel really uncomfortable because there's all this silence. And he says, I can't think of a way to make it better. And the patents are gone now, and I think that many of our the software automatic mixers that are out there are based upon noise adaptive threshold. I know even Sound Devices uses it. I think they call it Mix Assist, but it's basically noise adaptive threshold or IntelliMix into their small mixers. But eventually, we had to get into the analog or the digital world, and I grew up on vacuum tubes and had to learn integrated circuits and transistors. And though I use digital products, when I saw that train coming down the road, I said, Gino, take it over. So Gino is going to tell us about automatic mixing going digital. Right, Gino?
Yes, I will, because what happens when you can't get potentiometers anymore, you go to rotary encoders instead for your knobs. Yep. So, that's it's a great segue there to talk about auto mixing going digital. And as Michael said, for various reasons we had to start looking at these options, and in parallel to everything else that we're doing, of course we had some DSP engineers that were starting to try and figure out if they could model what IntelliMix does, so that we could start moving to a digital platform. And of course, we wouldn't be here talking about this if they weren't successful at it, but they were. But the interesting thing is that it actually allows for a lot of different possibilities beyond just the black box. But the first place that you really saw a Shure product come out that utilized the digital version of IntelliMix was the SCM820, which, as you might guess, is essentially a digital version of the SCM810 itself. In our naming convention, it's not totally obvious, but the 8s would be for 8 inputs, and the 1 would be for 1 output, which is all the SCM810 had, was a single bus mono mixer. The 820 isn't really stereo, but it does have 2 outputs, an A and a B output, amongst many other things. Primarily, remember, the primary design goal of the SCM820 was to make it as user-friendly and easy as the 810, right? So as Michael indicated,
SCM stands for? SCM stands for?
Sure Contracting Mixer.
Sound contracting. Yeah, okay.
Sound contracting.
Either way.
Yeah. See, the historian is quizzing me.
Mark that down, Jay. He missed the quiz.
Darn it. So we created this digital version of it that, again, was supposed to be as easy to use as the original 810. But the advantage of having a digital device is you can, if you wish, open up a lot more possibilities. So the SCM820 has an embedded browser-based GUI that you can get to from a computer, and it opens up a whole new world of configuration possibilities. So if you're an SCM810 type person who just wants some set it and forget it volume knobs, you could literally take out an 810, put in an 820, and be on your way. It works pretty much the same way. In their default state, those rotary encoders are just volume controls like you would have on an SCM810. But because the 820 is digital, if you would like, you can do lots of different things. Actually, even before opening up the GUI, for example, the button on the far left of the front panel underneath the Shure logo allows you to change the function of those rotary encoders from a gain knob to adjusting your low cut per channel or high frequency booster cut per channel, adjustments that you had to make with a screwdriver to a recessed potentiometers on the 810 you just do via that front panel control there. Again, also because you've got the ability, because it's a dual mixer, to do A and B outputs. So again, default mode, it's just, there's 2 output connectors, A and B, but they're basically duplicates of each other. But if you bring up the browser-based GUI, you can go in and actually route some inputs to the A output, some inputs to the B output. One of the best things, though, one of the coolest things, is the fact that you can change to different IntelliMix modes, we call them now, or auto mixing modes. The standard, again, out-of-the-box mode is what we call classic mode, which is the noise adaptive threshold gating that Michael just described to you. It's just a digital emulation of that, and it works just as well. And you would never know from listening to it that it's not the analog version of IntelliMix. But you can also choose what we refer to as smooth mode, and smooth is essentially an emulation of a gain sharing type of auto mixing. It's not exactly specifically the Dugan style of mixing, but it's very close for people who prefer more of that gain sharing style of automatic mixing to the noise adaptive threshold. And we didn't talk a lot about what gain sharing really is, but the idea is that there's a fixed amount of gain available, and the mixer distributes the most gain to a microphone that is being spoken into and less gain to microphones that are not being spoken into. So if one person is talking, that mic is getting the most gain, all the other mics are getting some minimal amount of gain. If two people talk, that first mic gets a little bit less gain so that they can give some more of that gain to the second talker, and it just sort of moves it around like that. Michael, please correct me if I'm not describing that correctly, but that's right. Essentially what it's doing.
That's right. Yep.
Good. And then we also have what we call extreme mode, extreme automatic mixing. And that's for really high noise environments or where gain before feedback is a real issue. And what extreme mode does is it essentially sets your off attenuation to infinity, to fully off, right? Again, in most automatic mixers, or like the SM810, 820, when the microphone is off, it's not really off, it's about 15 dB down or so. And that is to maintain a little bit of a more natural sound, right? Because typically you wouldn't want all the mics totally off, and 15 dB down is enough that you're not hearing any additional background noise, or you're not getting that buildup. But in an extreme circumstance where you're in a really noisy environment, you use this extreme mode, which when a microphone is off, it's off. And it also disables last mic lock on, which means that if nobody's talking, all mics are off. It doesn't leave that last mic active for you. So you can do that. And then there's custom mode. Again, if you want to, get your computer hooked up and crack open the GUI, you can go in and you can start tweaking all of those parameters. If you think 15 dB attenuation is too much, you can raise it or lower it if you want more. That's fully adjustable. You can limit the number of open microphones. Remember, an automatic mixer, an 8-channel automatic mixer, if all 8 people are talking, if the mixer thinks that there's speech at all 8 inputs, it'll turn all 8 inputs on. But through the custom mode, you could go in and limit that to 1, 2, 3, 4, whatever you would like your number of open mics to be limited to. It's pretty much customizable to however you would like to go in and customize it. So that's also available to you there. So again, it's a really nice best of both worlds in that you get all the advantages of the simplicity of the 810 if that's what you want. But if you want to go crazy, you can as well. There's also an optional Dante version. And something you should know about the 810 is that you could link multiples together. You weren't limited to just 8 channels. You could link, I believe, again, Michael, correct me if I'm wrong, up to 40 SCM810s together to create an extremely large automatic mixer. Good. If you would like to link 820s together, you would want to get the Dante version. So there's a version that doesn't have Dante, and there's a version that does. Again, for those of you who may not be familiar with Dante, that is a networked digital audio over IP protocol. So with the Dante-enabled versions, you use Dante to link multiples together to create, again, a larger array of microphones that you can auto mix together. So again, that's all done over Dante. And if you had the non-Dante version, you could get an optional upgrade card to turn it into a Dante version. And even later on, after about, I don't know, maybe 6 months to a year after the SCM820 was first launched, we also took our digital feedback reduction algorithm, which you may remember from the DFR11 or DFR22 is actually still a currently available product, even though it has a serial connector on it instead of USB. But you can actually use that digital feedback reduction has been added to the SCM820 as well. So really a very fully featured mixer with all kinds of great features. Once you take that IntelliMix algorithm, the noise adaptive threshold algorithm, and make it digital, you're not stuck though with just this one black box. So now we've been able to take that auto mixing that has been, again, beloved for so many years in the SCM810 and put it all kinds of different places in other types of DSP hardware, in digital microphones, and maybe even in a standalone software application. One of the I'll say negative comments we got about the SCM820 when it first came out was the fact that it didn't have echo cancellation in it, and therefore can't use it for AV conferencing applications. And that's a true statement, and it's a fair statement. The SCM820 was designed really for live sound reinforcement for churches, courtrooms, presentation rooms where there's multiple microphones. The city council example that Michael gave earlier, it really was designed with that, and not as an AV conferencing processor. Hence, that's why it didn't have echo cancellation. Turns out, though, Shure had also been working on our own acoustic echo cancellation and noise reduction algorithms. And with the success of our digital conferencing microphones like the MXA 910 ceiling array that you see there, the MXA 310 table array, the Microflex wireless system. Having a complementary DSP processor to go with that seemed like a bit of a no-brainer. And that's where we end up with the P300, which takes that it actually takes that IntelliMix automatic mixer, which you see represented by the light blue box in the middle of the screenshot there from our designer software, and combines it with our acoustic echo canceller, noise reduction, AGC, parametric EQ, compression, delay, matrix mixing, and gives you a now fully functional AV conferencing processor with the same auto mixing that is in the SCM820, just put into the P300 there. So we can put it in many different places, including the MXA 910 and MXA 310. Those devices also have the IntelliMix automatic mixing noise adaptive threshold in the device itself. So with an MXA 910, in a single mic application, you don't even necessarily need the P300. You could take the auto mix output of the MXA 910 and you could take that straight into a DSP with acoustic echo cancellation, and away you go. No, or you could even take it directly into a computer. If you're using the onboard there, auto mix out of the MXA 910, you can take it into a computer with Dante Virtual Sound Card directly into your meeting software of choice, your soft codec of choice, and away you go. So you're starting to find this IntelliMix algorithm in everything besides just the black box itself. And now, speaking of IntelliMix, a term that we're still being used, that what can get kind of confusing for people like Michael and myself that have been around IntelliMix for a long time, and Jay too, is that IntelliMix no longer refers to only the automatic mixing, the noise adaptive threshold part of it. Shure decided to expand the marketing cachet of IntelliMix and use it to refer to the suite of DSP processors you see here. So IntelliMix is kind of all of those things, which includes the automatic mic mixer itself. And I guess the final sort of evolutionary step there, again, as you see beyond it, going into the endpoints of the microphone, is actually having it go to software only. And that's what our new IntelliMix room, or IMX room, is for short. Again, totally removing the black box DSP processor from your AV conferencing room now. So it's replaced by a computer. Most conference rooms now have some sort of computer in them all the time, because soft codecs, again, Zoom, GoToMeeting, BlueJeans, Microsoft Teams, what have you, right? Like those are become commonplace in just about every meeting room and huddle room and every application nowadays. So if there's going to be a computer in there already, if you could throw your IntelliMix onto that computer, then you're golden. Right? You don't need a standalone box. You just need a microphone, a loudspeaker, a PoE network switch, and a computer, and that's your whole system right there. The interface for such a software should look very familiar. It should look just like the P300's interface, actually. So this is another screenshot from Shure's free designer software. But instead of having that black box of the P300, you're just running your IntelliMix DSP on could be an Intel NUC or something like that in your room, or any of a number of other appliances that are available by like Crestron Flex and other things like that are a dedicated room appliance for AV conferencing. You just install IntelliMix room on there, bring up designer software on another computer connected to the network, and configure your DSP again with that well-respected noise adaptive threshold gating living on that computer right there. And just as an aside there, in the room diagram down in the lower right hand corner there, now that's a complete what Shure is now calling ecosystem for AV conferencing, because we also have, in addition to IntelliMix room and a new linear array microphone, the MXA 710, there's also a loudspeaker, which is a Dante-enabled loudspeaker. So you're wiring up your whole system pretty much using Cat5 at this point, except for maybe a USB connection from the computer or something like that. But it's all kind of running on an Ethernet backbone now, so very IT-centric world that we live in, as I'm sure you all know. So, Michael mentioned a world of tubes and transistors. Now it's a world of IP addresses and network switches. So it's gotten to be a different skill set and a learning curve if you've been in the audio industry a while. But it's been exciting to see how this kind of technology like auto mixing has really evolved and adapted to kind of keep up with the times, especially if you compare it to the photo we looked at of Dan Dugan from 1980 with his rack of devices there taller than him that was required for auto mixing. It's quite interesting, but we're excited about where these things are going. So I believe that brings us to the end of the formal presentation portion of the evening. But I will pass it back over to Jay for Q&A.
Yeah, so there are a couple of questions. The first one, I was kind of curious. What exactly did Michael find in the Shure archives? I'm pretty certain that they're referring to the Dan Dugan hippie print letter offering his, services in the automatic mic mixers.
Well, but maybe it's a bigger question. The short version of the Shure archive is we have at least one of every product that we've made since 1932. And then we also have probably 100,000 documents and probably 20,000, 30,000 photos as well, and plus video and audio as well. I did find that Dugan letter in the archive. I stumbled across it, basically. But my job, and I've had 5 careers at Shure, and this is the best job I've ever had, is literally just to research our history and write interesting stories and talk about that. And they go on and they go on and on. So I'm not sure if that's what the person asking the question wanted to know, but I found the Dugan letter in the archive, but the archive is just truly an amazing resource. And Mr. Shure started it when he started the company in 1925, and here it is 2020 now, 95 years, and it's a heck of a great resource for us.
Yeah, there are certainly a lot of treasure there. Oh my goodness. Okay, so we have another question here. Do automatic mixing systems offer a provision for priority microphone for a moderator or a master of ceremonies, also known as chairperson?
Gino?
Sure. The short answer is yes, they do. Depending on whether or not you're using an analog or a digital mixer would be different ways of setting that up. So a feature of most automatic mixers that we sort of glossed over, we didn't really mention very much, is the presence of what's called TTL logic, right? And that is a system, an analog way for you to get various different control functions or other things to happen external to the automatic mixing itself, right? For example, let's say you wanted to have a chairman mute button, right, where the chairman has the ability to mute everybody else. You would wire up a switch to the TTL logic ports on the mixer such that when those specific ports, they're called the mute pins on an SCM810, get grounded, it forces all those channels to mute. And you could set up a similar thing for an automatic mute where anytime the chairman speaks, there's what would be called a gate out pin for that chairman's microphone, and when that gate out pin goes logic low, you could wire it up in a way that it would mute all the other microphones, and so that person becomes the priority speaker. Anytime that they speak, it mutes everybody else. You can still do that with something like an SCM820, but instead of wiring things up to logic terminals, you could you might have to do some wiring to logic terminals, but you would go into the GUI and do the configuration that way over the computer, and you can set up different sorts of chairman mutes and overrides and all that sort of stuff. But if you ever want to see how some of that stuff is done, especially in the analog way, just get the user guide for the SCM810 off of the Shure website, and there's a whole section of suggested logic applications, loudspeaker muting and that sort of thing, as well as internal modifications where you had to pop the lid off the thing and remove 0 ohm resistors and put jumpers in place and all that sort of stuff to make it get these different functions. But yeah, still possible, just handled in a different way now. So if you don't have a soldering iron anymore, you can do it.
We do it done with the SCM810. No, I guess it was AMS. Doesn't make any difference, but it was in a church, and they wanted that whenever the pastor would walk up to his microphone, and it would mute all the other microphones in the church because he would only be standing there when he was giving a sermon. And he didn't want it to be voice activated because he might cough or something else. So we actually used a floor pad that had a switch on it. And so when he stood on this area, that turned the switch into the floor pad, if you will, and then that muted all the other microphones. And when he walked away, the switch would go off and all the microphones could activate. So you can do it with mechanical means as well.
And another application for that, speaking of house of worship, is a lot of times you'll have the pastors wearing a wireless lavalier microphone, and there'll also be a podium microphone, a gooseneck podium microphone. And if the pastor is not remembering to turn his lavalier off before he approaches the gooseneck microphone, you'll have both mics active. They'll be at different distances, which comes back to the whole comb filtering that Michael talked about at the beginning, right? You want to avoid that. And having a pastor double mic with a lavalier and a gooseneck on the podium, that's a recipe for bad sound. So with the SCM810, you could set up well, actually, now that I think about it, you don't have to set up anything. The Max Bus will take care of that for you, right, Michael? It'll know which mic is getting.
Yeah, most of the time, even though the Logic thing would be more reliable. But yes, the Max Bus would take care of it. But you can fool it in some instances.
Yeah. Yeah, and that's why, you probably would want to wire up Logic to give priority to one of the microphones so that it's a little bit more solid there, and it doesn't there's no question about which microphone is going to activate when the pastor approaches the podium. But that, speaking of podiums, that just lead to another application, right, which is when people want to put multiple gooseneck microphones on a podium, and the auto mixer is your best friend there. And a lot of people think that more mics on the podium is better because the talker is known for wandering back and forth and they get out of the pattern of the microphone, so we'll just put more microphones up there. But again, if you have two mics on the podium, they're going to be at different distances. You're going to get that comb filtering. It almost starts to sound like phasing if the person moves back and forth between the two. So an auto mixer with Max Bus will go ahead, have as many mics on the podium as you want, but the Max Bus will only turn on one of them, and that eliminates, again, that comb filtering.
That's a good point. Steve Jolstrom, brilliant Steve Jolstrom, he built some hysteresis into this. So basically, when you had that situation like you just described, Gino, that I'm over to the left and the microphone on the left is on, and now the microphone on the right wants to turn on, but he set up the system so that microphone on the right had to have a 6 dB advantage before it would switch. So to stop that thing from bouncing back and forth from left and right, when the microphone that was going to switch had to be a 6 dB solider signal over the other one before it switched. So, Steve thought of everything.
I think another thing worth, since we're kind of talking about the house of worship again too, worth mentioning too is because of the way the noise adaptive threshold circuit was designed to look at speech instead of noise, you really don't want to use an automatic mixer for a musical application. So if you're putting an SCM810 or 820 into a house of worship, if you're going to run your choir mics to the auto mixer, you probably want to override those channels, force them to stay on, because musical program material can actually confuse the noise adaptive threshold. So a long sustained note, a pipe organ, all of those kinds of things will cause erratic gating. That used to be a common call that we'd get in applications engineering at Shure was, the choir mics are cutting on and off. And it's like, you're really not supposed to try and use an automatic mixer for musical program material.
Yeah, Dan gave up on that years ago. Dan Dugan did, because he wanted to also make something for music, and he basically decided, I think in the late 70s, that just can't do it because music is not speech. So
right, works great for speech, but not for music.
Yep.
So, Gino, this is probably a question for you. There was a question that came in addressing that issue about everything is all fine and dandy with the speech microphones. We're all good. And then the organ plays and then throws off. There were adaptations and solutions put into place to address that. Do you remember what those were?
Yes, that is the
sensing mic, right?
Yeah. That's actually, right. Michael, you could probably talk about that better than I could. The inhibit function.
Well, inhibit really was designed for filibuster. In that situation, what we would probably do is simply put a microphone up close to the pipe organ, make it so that when it came on, it would mute all the choir mics or whatever mics you wanted to mute, but then make it so that pipe organ audio did not come to the output of the mixer. So it was simply a triggering device. Yeah, and with the 810, I believe you actually had to go in and unsolder a resistor, or this, so that the audio circuit would not go to the output. But on the 820, you could just do that digitally. I think probably on the GUI. So in that
That's
case,
right.
Jay, it was just simply using, you don't need to run your pipe organ through a sound system. By the way, if you are doing that, don't do that, because the pipe organs are loud enough by themselves. But just use a mic that real close to when the pipe organ starts to play. That mic gate's on, and then that microphone, the logic output simply mutes the other channels. That's probably how I would handle that.
Okay. And that's
Very
often done in office applications as well too. If you've got a noise source, some sort of a fan or something that isn't on all the time but comes on periodically, you can also again set up a way to inhibit that sound as well. And that's because the noise adaptive threshold, when a noise source kicks on, like let's say there's an air duct right near your microphone, when it first turns on, that microphone might activate for a second because there was a dynamic change as the noise source started, and then it'll go off. So it's important to understand that the mixers are not predictive. They can't tell when the ambient sound is going to change. It has to change first, which might cause the mic to activate, but then it very quickly goes, oh wait, that's not speech, it's noise, and then it goes back off again.
Okay, I do have another question here. When you have multiple people talking at once, how do you choose how loud to make each talker? Is that based on trial and error, or was there an audiological research that went into it?
Gino? Yeah, I mean,
You're looking at me.
Yeah.
Well,
first of all, the 810, the 810 does not have any type of AGC in it, does it? The 810,
No.
I mean 820. I'm sorry, 810 definitely doesn't. Does the 820?
it does not. You have to get to the P300 to get to AGC.
Yeah,
But yeah, I think
There
your point
was,
of what you're getting at. Sorry, go ahead.
go ahead. Nope, I'm done.
So the automatic mixers don't do any mixing per se, right? It's better to call them maybe like a speech activated mixer or something like that, because that's all it's really doing again is, putting a microphone at full gain, which is whatever you've set the volume control at, or attenuating at 15 dB or all the way off if you've set it that right. So it's not doing any mixing in terms of trying to adjust the relative levels of talkers. And that is where the sound technician or the installer still comes into play, is like you have to sort of set some nominal levels based on the speech, the talker levels that are going to be in the room. And there's simply no way around that. You have to make that kind of adjustment. You might also be referring to the fact that when multiple mics gate on, that NOMA circuit is turning the output down by 3 dB. And again, the reason it does that is that's to maintain the staying below the feedback threshold, right? Again, every time you double the number of open microphones, you're 3 dB closer to the feedback threshold. So that's why every time the number of open mics doubles with an auto mixer, it turns the auto mixer down by 3 dB, so that you'll always stay within that feedback stability threshold and not go into feedback. So again, it's not trying to do anything with balancing levels. It's just keeping your system from going into feedback.
Mm-hmm.
Okay, very good. Another question here, and Gino, this one may roll towards you. Has the direction dependent auto mixing been translated into array products? Has the direction dependent auto mixing been translated into array products? Maybe companies, I don't know.
Well, that's not how Shure is doing it. So the direction dependent gating of the AMS system is unfortunately been retired into history. So that no longer exists. Array microphones like the MXA 910, MXA 310 are using multiple microphone elements, but for vastly different reasons. The gating decisions that are made would be in like an MXA 910, which has IntelliMix now. That's a noise adaptive threshold style of gating that is handled in digital. Again, doesn't have anything to do necessarily with the multiple mic elements. The multiple mic elements are used to just create the different patterns and lobes and steering and all that other stuff, cool stuff you can do with it. But pretty separate type of technology.
Yeah, I think one way to look at it, Jay, would have been the original AMS gave you a 120 degree gating window, but that gating window could never change. And of course, with the 910, the actual gating window, or if you will, the pickup angle does vary. So you couldn't vary it with just 2 elements. You can vary it when you have hundreds of elements.
Mm-hmm.
Very good. Just another couple questions here. Is there an ability for auto phasing detection?
Auto phasing
Gino?
detection. You mean,
Phasing
microphones that are out of polarity? Because out of polarity is phasing is not normally. Yeah, I'm not sure. Gino, you have any idea what he really means by that?
I don't know. I mean, it could be sometimes the comb filtering sounds like phasing, but again, that you wouldn't need to detect it because the auto mixer, if it's got max bus or a circuit like that, is gonna prevent that from happening in the first place. So
yeah, I'm afraid I just don't understand really what he was going at, Gene. I mean, if he wants to write in, write something a little more, we can answer it, but don't quite understand the question.
Okay, well, that's all right. Let's move on here. Is Shure using same familiar GUI for all products now? Basically standardizing GUIs.
That's Gino's.
All products?
Kind of in a way, I guess. So, yeah.
All products, sort of. So, so we've been coming out with products that have embedded GUI since the 820 and the Microflex wireless system. And we are kind of moving towards a less control in the GUIs and more in a standalone piece of software that I referenced earlier. It's called Designer. It's free, and we are somewhat slowly evolving towards an era where you will start using Designer as the way to control and configure all of your DSP based or digital devices that have in the past had their own GUIs. And that's not going to happen overnight, but we certainly are moving that towards that sort of an architecture. And there's several reasons for that. Number one is like referencing familiarity, right? Like if it's one piece of software for all of them, then you don't have to, relearn a new GUI every time. And just from an efficiency standpoint on our end, you don't have to keep reinventing the wheel every time a new firmware or new product comes out and you got a new GUI. Now it's like you just kind of keep modifying the existing software that works for all of those things. So hard to say target date when we're going to get to that point where it's all in Designer, but you're certainly starting to see more and more products go that way.
Yeah, very good. I think we're getting pretty close to the end of the program here. I do have one last question here, and this one will be directed toward Michael. Yes. Once COVID is over, can we get a tour of the archives?
Well, perhaps.
Who's we?
Yeah, exactly. Who's we?
Saw through that, didn't you? All right, okay.
Yeah. In general, here's kind of the rules. We don't allow anybody in that's under 18 into the building just because of liability issues. If you're in the industry, particularly if you're a dealer or something, your first choice would talk to your local rep, like Jay, and then Jay might be able to set up something like that. We have done tours sometimes for large college groups and large, I'll say, up to 15. We really can't take any more than that just because of the size of it. But always for that, the first step would be to talk to the Shure sales rep that's in your area to investigate. It's not open to the public, so to speak. It actually is fairly crowded back there. We do have on the first floor in the Niles building a really nice, we call it the Great Hall, which is kind of a mini museum. And that's really a lot of the things what we have from the archive. But I would say possible. And the first thing to do is talk to your local rep, and they can kind of start the ball rolling from there. It's a pretty amazing place to be. Just a quick story. Before the COVID thing started, I went back there, I think it was in early January, and just pulled a box off the shelf just at random, just to look in there. And I found in there a 16 millimeter film shot in 1943, and it's photographs of the Shure manufacturing plant making war microphones. And it was just, unfortunately, we actually have transferred that to digital now, and it's just amazing footage. Plus, it had the earliest moving footage of Mr. Shure that we found. So literally, with 95 years of history, it's like going back and looking in grandma's attic every day. It's really a great fun. And I can't wait to get back there because I haven't been there since March.
You discovered quite a few interesting little nuggets, too, when you moved from Evanston to Niles.
Yeah. Anything in particular you think about the Unidyne prototype? Is that what you're thinking about?
Thinking about some of the stuff that was on the floor of the anechoic chamber, perhaps.
That was the Unidyne prototype. So your listeners or audience may know that probably the most famous Shure microphone is the Unidyne 1, the Elvis microphone, the birdcage microphone, the click in this logo in the upper right-hand corner of your screen microphone. And when we moved from Evanston into Niles, which was in 2003, we were looking every place in Evanston. We had been there in Evanston since 1956, and someone crawled underneath the anechoic chamber for some reason and brought out this box. And on the side of the box, written in pencil, it said Unidyne Prototype 1937. And we opened it up, and it was a carved wooden prototype, design prototype, not a functioning prototype, painted in silver. And it is so Art Deco and so cool. And we have that in the Great Hall. So yeah, things like that. It's so much fun. And right now, I'm even more excited because we've got a new software package for the archives, and we're gonna have to go through and pretty much touch everything that's in there, at least for the artifacts. And so every microphone that's in there now, we're going to see if it operates and then make recordings of them. So we'll actually have a fairly large recording of vintage microphones, because microphones in general, they work forever.
That's awesome. Thanks, Mike. Yeah, Michael, Gino, thank you so very, very much.
Our pleasure
for taking your time out of your evening, your valuable time. We certainly do appreciate it. Nate, do you have some closing things there?
Yeah, I'll just wrap us up here. Again, thanks, Michael and Gino, for that great presentation. I hope everyone enjoyed it as much as I did. Before we close out the evening here, I want to remind everyone to hit the like and subscribe button on this YouTube channel. Also, check out the Audio Engineering Society's website at aes.org for all the latest society news, research, benefits, and announcements of events just like this one. If you're not a member yet, I highly encourage you to check out what we have to offer. That's aes.org/join. You can find out all sorts of information right there. Also encourage you to become involved in your local section, whether that be local or regional for you. For more info on the Central Indiana section of the AES, you can visit centralindianaaes.org. We have a mailing list there. Go ahead and join on that for news and updates and events just like this one. Also, we'll be sending out a post-event survey tonight to all of our registered participants, so please fill that out. We rely on your feedback to help us develop similar events in the future, and it helps us put together these events for everyone, especially as we move online. So please let us know how we're doing. Again, huge thanks to Gino, Michael, Jay, thank you for hosting us tonight, and thanks to everyone for joining. I also want to thank Central Indiana Section Executive Committee for planning tonight's event, as well as Force Technology Solutions for providing the production facility and logistics to make tonight's event possible. I think that brings us to a close for tonight's webinar, so please check out centralindianaaes.org for more info. Again, thanks for joining us. We'll see you soon.